Okay, this means you have to do the tools UENEG006. This is for the AC machine. AC machine include the transformer and also the electrical motor, AC motor. So that those are the nodes. So you are 23rd July, lesson 22, International English Bachelor of Applied Engineering EE. So those are the nodes power transformer G040. You have to download those nodes. And also those are the electrical machine. So this is the motor. So you can do to download those nodes. And video are here, power transformer video. You see the GIS73 power transformer video. So the highlight computer video lesson.html. So to download this page, and you look at the page at 271 to 284, those are the power transformers. So that you view those videos, those are power transformers. In the meantime, you also see there's an AC machine. So AC machines are from you download those nodes, and page 3080329, those are AC machines, AC motor, so that you need to view the those video. So the G006 is basic G06, G043, G040. Those are the combination of the power transformer, AC machine, electrical motor, AC motor. Those are lessons. The lessons are common to the both electrical trade and electrical diploma. So those lessons you can see the G06. You need to download this node. This is for the power transformer. Also this node. This is for the AC motor. And then videos you can view those videos. Those are video lessons for the transformer. Those are the video lessons for the AC motor. So this is the way you can study for the both electrical trade and the electrical engineering. And regarding the G108, this is the form winding. So this thing you have to accept this thing. So that I accept this thing here. For the distance you see the G0108. So distance here you have to accept the link. And workbook is here. You download this workbook. So this is the workbook. Workbooks are included those question answer here. Workbooks are all question and workbook answers are here. For the G108 is the four findings. Four findings are question and answer. So this is the workbook. This is my answer for the workbook. So that you have to download the G108 workbook as well as the answer. So you look at the workbook and also study the answer. So this is the way you can study the G108. So this is the workbook and answer. So those are the answer for the workbook. And you have to view the video. So those video you need to view the video. So all the delay video, all the troubleshooting, all the electrical apply, those video you need to view. So this is for I talked about I provide the instruction regarding the G006. The G06 and is a combination of the power transformer and AC motor. So those are I provide. And G108 is an electrical fault finding. Those electrical fault finding lesson you can also view from here. So this is I provide the workbook and workbook video. So this is for the workbook lesson, workbook provide, and you also see the answer. Also that you need to view those troubleshooting concepts. So this is it. I provide the lesson for the G06 and G108. And regarding the G109, this is the control circuit. The control circuit workbook is here. So that you can download the workbook from this side. You do this side here. So this side you can download. You go to here and you download the G109. Click the G109 and view the workbook one. So I will explain you about the workbook one. And also you also need to view that those are detailed video lessons. How the time delay, how the timer relay, how the circuit using the contactor, everything you can view this video. So what I do is there are two workbooks. One workbook is workbook 1 and workbook 2. That's the same full workbook. One is published in by the Western Australia. Another one is a New South Wales workbook. So these two workbooks I explain you about. Okay, firstly, workbook 1 is this is the workbook 1. This is the Western Australia workbook. So that you read this workbook, and what I do is that I pick up the sound of the pages. I explain you the sound of the lesson. So this is for the basic simplifies electromagnetic relay circuit. Here you see the switch. So this switch provide the control circuit. This is the energized coil. When this coil energized, the coils attract the armature. Then this one will be this two contact will be closed. Then electrical current coming from the passing through the power contact go to the load and then go to the neutral. So this is the simplified electrical circuit. Circuit simplified for the electromagnetic relay. Simplified electromagnetic relay circuit. The next one is page 21. Page 21, this is for the first one is a real connection diagram. So this is the connection diagram. Here is there are two part of circuit. One part of circuit is the control energizing circuit. Another one is a power circuit. So this one we can develop by this way. This is a 12-volt battery connected to the relay contact bus button. So this coil is energized and is controlled the relay contact. When the relay contact control, the load can be energized by the battery. So this is the two part of the circuit, control circuit and power circuit. And then this two circuit can be combined by this way because of the here you see the two battery. Instead of using the two battery, you can use a one battery. So one battery can be utilized to control the relay coil as well as another is also the same for the power circuit. So one battery utilized to control both the share voltage source. So this is what page 21. Control circuit and the power circuit, they share the same voltage source of the 12 volt. And page 26. To the page 26. Page 26 is a simplified wiring diagram of the three-phase direct online starter. So this direct online starter, this is a three-phase motor. This is a three-shelf supply coming, and then this is a three-main switch, and here is the control overload connected to the motor. Here will be the control coil. So this is the control coil. This control coil control the start-stop. Those start-stop wire are controlling this control coil. In the meantime, is also the damage overload. So this damage overload will cut off the control circuit. So the whole circuit diagram you can see there are two parts. Electrical power go to the three-phase circuit and passing to the three-phase circuit go to the motor. And here we see this is the control. K4 is a control. So that control coil, this control coil energized. When the start-stop buttons are controlling the control coil to energize. And in the meantime, this control circuit we also connect the damage overload. When the motor damage overload is cut off the control circuit. So this is the simple wiring diagram for the type online motor starter. And page 27 is a this is for the VSR wiring diagram in the block. This is a simplified. So here with this one is the three-phase circuit, and here is control circuit. Control circuit line 1 and line 2. Line 1 to neutral, so this passing through the start-stop, and also this is the start contactor. This is for the damage overload, and this is stop switch. This is a start switch, and this is the bypass switch. We can connect it to the motor. So this one is a controls, and this one is a freezer circuit. So this circuit on and off, we can bypass this one. So this one is a controls contact, and here is the bypass switch. Both one control the start switch. So there's a line to the neutral, and also this is the line to three-phase connection diagram. So this is for the page 27. You can see. So this is a normally open contact. This is a normally closed contact. So this is the symbol of the lamp, relay coil, resistor, fuse, and a battery. So you see there's a left to right. So this is the energy flow to the, and also this is for energy flows are left to right and energy flow top to bottom. So dead conductors are represented by the vertical and the horizontal line. So this is vertical and horizontal line. Also, you can see the circuit diagram. These are the junction. This is the wiring diagram. Circuit diagram is you see the circuit diagram this way, and this is for light. So we can draw the wiring diagram like this way. And here is a control circuit diagram. This will be the store switch, store 1, store 2, and this is a start switch, and this is the relay one. So this is the you can see there's a control circuit diagram. Then here is also this one is a three-phase switch, and here thermal overload. And also this is the start stop switch, and this is a control circuit. Its wire are connected like this way. This is the junction, and they are not blue. We can draw this one, junction or not junction. You have to draw, but you should not draw this way. And here is a number of contact operated by the conductor relay. So this is the conductor relays are controlled the K11, K12, K13. They are operated by the K1s conductor relay. The K1 conductor relay connected between the phase and the neutral. They are start source. They are connected in series. Here with the horizontal format. Horizontal format is the signal switch. Also, this is the vertical format. The horizontal format representation. Coil and lens are horizontal format, and this is the vertical format representation. So if you connect a switch like this, you should draw a switch like this, but you should not draw like this. And this is the clockwise connection. You should draw like this, but you should not draw like this. And this is symbol a component can be drawn in the ends are orientation vertical or horizontal. So you can draw any vertical or horizontal. A small circuit representing the open and closed contact can be permitted, as long as the symbol in the drawings are consistent. This conductor can be drawn so that they pass around with the symbol. So that this one, this is the ways we have to draw how the conductor, how the switch can be represented, how to draw the diagram. You can see in this one. Here is a letter code. Letter code means C is capacitor, E is a miscellaneous, A is a protected device, G represents the generator power supply, A represents the signaling device, K represents the relay conductor, M is a motor, P is a measuring equipment, O is a mechanical switching device, R is a resistor, A is a switch, T transformer, U modulator, changer converter, V semiconductor, and A is a terminal plus. So this is the letter code and the data symbol. So this is for the typical wiring diagram. So this is for the typical symbol used for the circuit diagram. So this is a three-phase conductor here. There are fuses and the conductor K1, K2, K3, and connected to overload to the motor. And this is the control circuit for this circuit. This K1, K2, K3 motors are the contact. This K11, those conductors, you can see the those conductor. This is power supply. This is transformer connected to the AC to DC converter, and those circuits are operated by the DC circuit. So this you can see the switch, and also the this K1, K2, K3 conductor is a K1's control coil. In the meantime, K1, 4, those are the auxiliary contact, and also this is for the signal contact for the H coil. This is the timer switch, and also this light. So this is lighting. So those are this circuit going to the motor control circuit. The motor control circuit, this is the power circuit, this is the control circuit. Control circuits are controlled by the DC supply system. So the appropriate the switch they are the those K1, K11, K12, K13 are controlled by the K1s are holding coil, and those switch are the start and stop switch, and this is auxiliary contact. In the meantime, we can also see the timer. The timer switch is the K2 timer switch. In the meantime, this timer signal lights are also you can see. So this is for the connection of the motor control as well as the timer switch. Simplified diagram. So this is for the C1, means that this is the Athens symbol. This is the conductor, and this is for the conductor in cable. This is the terminal, junction conductor, double junction conductor, conductor crossing, Here is the plug and socket connecting link. This one is the resistor generator, variable resistor, variable dependent resistor, voltage dependent resistor, potentiometer, capacitor generator. This is the resistor, polarized capacitor, variable capacitor, capacitor with reset adjustment. In the middle, you see that this is the inductor motor, induction inductor winding, this is the inductor with the two-phase contact generator, motor, the motor three-phase motor, three-phase motor, a single phase, thermal overload heater, this is thermal overload contact. The transformer, auto transformer, current transformer, three-phase transformer, battery, voltmeter, lamps, and discharge lamp, and bell. So those are symbol utilized in most of the electricals are contact. So this is for the make or make switch, and this is for the make contact or switch, breaker contact, chain over switch, make contact delay closing, the break contact delay, switch manually operated switch, push button switch stop, push button switch start, push button switch stop. Here we see a down switch locking, limit switch, the contact limit switch, the contactor contact, this is contactor. Normally it's open contactor, normally it's closed contactor, circuit breaker, isolator, and operating contactor, time delay relay, and this is fuse. So those are symbol of the electrical symbol utilized in the electrical control circuit. And this is a page, page 49. Page 49, you see there's electrical. This is for the start and stop. Forward reverse contactor system. So this is, you can see the three-phase motor wiring diagram, three-phase motor connection, start stop switch, also three-phase motor 1, motor 2. Two motor is control the wiring. This is for the both control circuit and the power circuit the diagram. You can see the two motor control system. So page 49, you can see the motor control circuit for the two motor 1 and motor 2. You can see that this is the power and control circuit diagram. This is for the page 49, you can see it. And also we can look at the page 53. Page 53 is that this is for the third motor, is you can see the rears motor terminal. So this is terminal wiring, line terminal. This is for the output wiring, motor terminal, start button, stop button. So those stop button, all the power circuit, and also input, and also output to the motor. You can see the this terminal block. Page 55. Page 55 is this circuit you can see for the symbol. So this is all the contactor switch, all the switches are contact inside, and also start stop switch. The control, this is thermal overload. So that control and wire power circuit and the control circuit switch, you can see inside connection, you can view by this way. So this is 55. Page 60. This is for the motor, three-phase motor circuit. This is the power circuit, K1, K2, K3 passing through. And this is three fuse and connected to three-phase induction motor. This is the drive online motor control circuit. This is start switch, stop switch. This is the auxiliary contact, and this is the holding coil. So between the line 1 and nuclear, you can see the drive online motors are control circuit. You can see it. And page 62. This is a time delay relay. So this is the delay on energizing and delay on de-energizing. When the delay energizing, that will be you can see the delay on energizing connect time delay. This is what delay on de-energizing. So de-energizing means that when you energize, it wait for some time and operate. De-energizing means the original operation, but after some time, it will be stop the operation. So this is the energizing and de-energizing circuit. So the energizing circuit can be represented by this diagram. De-energizing circuit can be represented by this diagram. So this is the time delay opening and closing contact. This is the time delays are closing, and time delay. This is the time delays are opening. Time delay opening and closing contact. You can see it. And also time delay can be controlled by the pneumatic or electronic or electromagnetic. So then we use a pneumatics air power, electronics, you can use the electronic circuit, or that we can also use the electromagnetic. Electromagnetic, we use a spring and we can wait for the time delay. Electronic circuit, we can use the electronic circuit to control pneumatic function, also we utilize. So this is the how to work out the mechanism we can use for the time delay. And this is for the motor connection. So this is the three-phase motor here, three-phase contactor, and here will be the bypass switch, resistor, and also bypass it. And this is motor. So this means that at the starting ties a motor usually draw the higher current. So the tools are reduce the motor starting current. We have to connect the resistor in series, and after the motor got the full speed, those resistors need to be bypassed by the K21, K31, those switches. So then motor will get the full electrical supply. So this is what the motor control circuit tools are controlled to reduce the motor starting current. So that kind of circuit diagram you can see. So this is the line connection, this is the line neutral connection. So that neutral is a basic circuit diagram. So you can also do this local switch and also remote control switch also. So this is local and a remote control switch. Remote control switch, local switch the switch located close to the motor, but the remote control switch is somewhere far from the motor. So that kind of the two control switch can be control the motor's holding coil circuit. The holding coil circuit control the motor, control the main contactor to the motor. So this is the remote control switch. So this is the diagram of the local and remote control switch. And this is the time delay. In this case, you connect the control. This is called the holding coil. And here you switch. This is the time delay function. So that you can control the drive or that you can do this time delay function. So time delay function control, you can be utilized by this way. This means that when you connect, firstly, the time delay contact will be energized. So that after some time, this the main coil energized. Then motor will be the control. So this means that by connecting this circuit, firstly, you have to energize the time delay function. So electrical current flow from here, passing through the K1 pole, and time delay function is energized. This time delay function, energizing the time delay functions are with close. That's the contactor switch. This contactor switch is controlled by the time delay switch. And after some time delay switch, because the time delay function switch, the contactor switch will be closed and the holding coil will be energized. So this is controlled by the time delay function. So basically, you can see the control circuit for the time delay function. So that time delay function contactor can also be utilized. So here, this is look at the remote control system, look at remote. This is the time delay function 1. So when you switch on, the time delay function 1 switch will be energized. So this electrical current passing through the time delay function 1. When the electrical we switch on, the current control, so that you can control the local remote and the bypass. Firstly, the TDR1 coil is energized. The TDR1 coil will close this switch, but it will for some time. After that, this switch will be closed, so the K24 will be energized. K24 energized, so then appropriate switch to the so appropriate main code that are controlled by the K2 ports are closed and it make the operation. Similarly, this one the K1 port is already energized, so it make the operation. So this is a K1 port is directly controlled by the switch, but K2 port contact is depending on the operation or the time delay function. So when you switch on, the electrical current directly flow to the K1 port contactor. Contactors are energizing coil, then all the contacts controlled by the K1 port energizing coils are closed and it make the operation. And after that, similarly, when the K1 port is closed, the electrical current also flow to the TDR1's holding coil. The TDR1 holding coil is energized, but this one depending on the time delay. After some time, the TDR1's contactor is closed and the K24 coil will be energized. So by energizing the K2 force holding coil, so appropriate conductor control by the K2 force will be operate. So this is the way this is the basic operation function of the time delay. So this is the we can see that that's why also you can see the TDR1, TDR2 time delay function you can use. So instead of using this time delay function, we can also replace with the programmable logic supply system. So in this case, time delay function, the main time delay function, the function provided by the TDR2. This is for the electromagnetic wave. But electronically, this TDR2 can be represented by the programmable logic controller. By this way, we can utilize the computer control and the PLC and electronic control system. So this is the basic principle of the time delay function. So you can see that more this diagram regarding the time delay function. And then you can see the page 77. So this is for the power reverse connection. When you for all the motors are connected, so the motor will be operate. But the reverse connection means that line 1 is connected to line 3, line 3 connected to line 1. So by this way, reverse motor will be reverse. So this is for the main conductor arrangement for the power reverse motor, and this is for the control circuit for the power reverse conductor. So this control circuit you include the forward and the reverse holding coil, their supply, and also the appropriate signal line. Whether forward is operating or reverse operating, you can see the signal line. So this is for the main power circuit for the forward reverse conductor starter, and this is for the control circuit for the forward reverse starter. Page 79. So this is the combination of the forward reverse. So start with forward reverse wiring diagram. So wiring diagram is connection. This is for the motor, forward switch, reverse switch, and remote control. Forward reverse start-stop button, and fuse wiring diagram. So this is for the line diagram of the forward reverse motor. This is for the forward reverse main power circuit. This is the main control circuit. Simplified diagram. This is the combination of the forward reverse motor control, forward reverse starter. It includes both control and power circuits connection diagram. So this is what is simplified. So you have to take the practice. You have to draw the circuit and the forward reverse conductor. You have to redraw this circuit. And so they are component of the forward reverse. So this is the you do the circuit exercise. There's a control circuit component, and this is the control circuit component. You need to do the practice. Page 84. So this is control of the two motor control circuit diagram. Two motor control circuit diagram. You can see for the here motor 1, motor 2, and also control circuit. You can see there's a motor, also timer delay control circuit, electronics control switch. You can see two motor control circuit diagram. Two motor control circuit direct online starter you can see in this diagram. So this is you can see on the page 84. Page 86. So this is the details of electrical wiring diagram. Wire control. This control is a motor starter switch. So that when motor is starting die, it will draw the high current. So that this current need to be reduced. So the R2, R3s are connected in series when the motor is at the starting die. And when the motor is got this motor got this momentum, then the switch will be bypassed. So that this R2, R3s are bypass switch you can see the control by the time delay control switch. The time delay control switch are the energizing the conductor for the R2, R3. When the motor got a speed up, that R2, R3 switch will be bypassed. So the bypass switch is controlled by a time delay function. So this start stop switch. So by closing the start switch, the time delay function is energized. So at the starting conditions are all R1, R2, R3s are connected in series to the motor, but after some time, this tidally function bypass the rules these are the system. So this is for the main conductor, and this is for the connected to the motor. So this is the in this case you also utilize this motor in also the start and the stop. So this group is for the starter. Startings are forwards are conductor. This is the reverse are conductor. So this means forward and the reverse. Forward reverse, the motor can be rotated in the forward reverse, and also the R1, R2, R3 is we can control the motor starting current. So this circuit diagram you can see, and this is the page 87, page 90. Page 90 is a two-star switch. So this is a typical case of other case of wiring design diagram. So this is a practical project. Switchboard, tire on starter, start station, and motor. You have to do this circuit diagram. So this is ways you can see from the page 90. Okay, so G109 today lesson, I explain you what to do. So firstly, you need to download this on my page. You need to download this note. So this is you download the workbook and you view my video and you study the workbook. So the page 1 to page 19. So my lessons are cover the page 1 to page 19. So this is the G109 lesson part 1. So next time I continue the G101, G109 lesson part 2. So this is the control circuit. Okay, up to this stage I talk about the GWC. GWC is include the transformer and the AC motor. And I give you the which note to be download, which video to be viewed. And also G108 is the electric fault finding. The fault findings I give you the logo answer for the logo and also the video. You can study that G108, G108. And now I talking about the G109 control circuit. The control circuit, these workbooks are from the page 1 to 90. I pick up the lesson, my lesson notes, and then you view this video, and then you have to study the notes. So this is for the electrical. In the meantime, advanced diploma electrical engineering, you should go to this site. So the Bachelor Applied Engineering Electrical Electronic Resources 1.htm. Then you can this link you go to the electrical diploma. You go down here electrical diploma. Electrical diploma 2022. You have to look at. Go down. You look at the until you see the electrical diploma 2022. Electrical diploma 2022. Click this one. Then you go to the video lesson. Going down, you see the YouTube video for electrical engineering lesson. So YouTube video electrical engineering lesson, you click this one, click the lesson. Click lesson, and then you see the IS73 power transformer. Go down here, and then you see the IS73 power transformer. G040 and IS73. Okay, this is G040, the IS73 power transformer. So this power transformer, this name, highlightcomputer.com/video lesson.htm, video lesson.pdf. So you download this note, look at the page 271 to 284. So those are the written note for the video. Then you have to view the whole video. View the video and you read the notes from the page 271 to 284. So this is for the advanced diploma electrical engineering. I told you what to study. And then regarding the Bachelor of Applied Engineering, we have to do the G1 or 2. G1 or 2, AC circuit, AC principle, lesson 4 and 5. Today I will study. I will explain you. So this is a lesson 4, G1 or 2, lesson 4, CDRS circuit, RSC circuit. I will explain you about the CDRS circuit. So this is a sort of program of the low voltage AC circuit, CDR series circuit. So that at the end of this lesson, students should be able to determine the circuit quantity and characteristic of the RC CD circuit, draw and label the impedance and the power target for the RC CD circuit, draw and label the phasor diagram for the RC CD circuits, state the effect of and calculate the frequency of resonance in the RC CD circuit. This is number of practical application for the RC CD circuit. So those things you can do some study. So this is the typical case of practical CD RC circuit. So the electrical current flow, this is the inductor coil, this is the resistance capacitor. So the current will be flowing. So the voltage across the resistor is in phase with the current. And the voltage across the inductor lead the current by some angle less than 90 degrees. And the voltage across the capacitor let the current by about 90 degrees. So this is the ways of RSC current and voltage in the RC circuit and the RS circuit. Then can be resolved by finding the applied voltage. So this is the applied voltage is a black one. The voltage phasor diagram. So in this case, you can see the VI, the voltage across the resistor, VC, AC, the voltage across the capacitor, VA, the voltage across the inductor. It can be resolved. So firstly, VA has a component H and VH and VIL. And also the quickly as the VRD equal to VR is a in phase, and VAC is a VH minus VAC. So this is a VA. Then you get to combine. This is the video square root of VR plus VR square plus the VH minus VAC the whole square. So this is the way we can draw the voltage diagram. And at this angle, is tangent inverse VH by VRD. The same thing happened with the impedance of triangle. So in this case, let's say star AC and ZL. There is a component H and IS. So this horizontal IS, vertical is HL. In the middle, we give us a RD equal to R plus RL. And the H equal to HL minus AC. Then combination at the red one. Black one is it has Z equal to square root of R plus I the whole square plus HL minus AC the whole square. Theta is tangent inverse H divided by RD. So the present conditions are occur when the H and AC. When the H and AC equal, that will be the resonance. At this point, H minus AC H equal to 0. Therefore, the RD equal to R, Z equal to R. Theta equal to 0, and the power factor is 1. So this is a special condition. When the H and AC equal, that special condition happens. This condition is known as a resonance. So you can see this. We can see the frequency and the opposition to current. When the frequency is there's a resistor RT, and this is the HL equal to 2 by FL, depending on frequency, and then we can draw the Z equal to square root of R plus I square plus HL minus AC square. So this is the black graph, depending on the you can see for the impedance. And the resonant frequency F0 is 0, And the times are Z equal to RD, A equal to H, H and R is C. So therefore, as the resonance frequency F0, Z equal to RD, H equal to HC. So that's where the circuit impedance minima as a resonance frequency. So the resonance frequency can be calculated at the resonance frequency 2 by F0, this is H value equal to 1 by 2 by F0 AC value. So the time resonance frequency equal. So therefore, the F0 can be calculated 1 divided by square root of 2 by into square root of SC. So the special calculation, we can see that Z equal to V by I, Z equal to square root of R square by A square, H is 1 by 2 by SC, H equal to 2 by F. Sin theta is H by ZD, cos theta is R by ZD, tangent theta is H by RT. So this is the sin theta equal to the Q by S. Q is a reactive power divided by apparent power. Cos theta equal to the P by S. P is a real power, A is a apparent power. Tangent theta is Q by B. So this is the reactive power divided by the real power. F0 can be calculated 1 by square root of 2 by square root of LC. In this case, S equal to V I. V is the voltage, I is the current, P is the VI cos theta, Q is the VI sin theta. So this is the power triangle, you can draw it. So this calculation, we can see the 0.2 H Henry and 0 O supply capacitor is 63 microfarad, that is like 15 ohm. Supply frequency PD is 230 volt, frequency 50 hertz. We have to find out the H, A, T, Z, I, theta, voltage. So then firstly, you can plot the H equal to 2 by F. And then you get the 100 multiplied by 0.2, you got the 62 by 83 ohm. H equal to 1 by 2 by AC. So the 2 by FC, so therefore 1 by 2 by 100 by multiplied 63 microfarad, so 55.3 ohm. Z has to calculate, Z is the square root of R square by A square, so the square root of 15 square plus 12 by 2, 3 square, so you got a 90 by 4. I need to be calculate, I equal to V by Z, so 230 by 90 by 4, so there will 11 by A6 ampere. Theta need to be calculated, theta cos inverse R by Z, so that will be the cos inverse 15 by 90 by 4, you got a 39 by 36 degrees. Voltage equal to IR. Therefore, the 11 by 86 multiplied by 15, you got a 177 by 9 or 4. Voltage equal to IHL, so the 11 by 86 multiplied 62 by 83, so you got a 745 by 17 volt. Voltage equal to IH3, so that will be the 11 by 86 multiplied 3 by 53, you got a 599 by 29 volt. This is the way you calculate the HACZ, current, and voltage. So this is the when we have to draw the diagram. So that way the 0.8 Henry 0 ohm, 63 microfarad 15 ohm, VD 250 30 volt, frequency 50 hertz. So the current is 11.86 ampere. So the voltage VI is 175.9 volt, and then VA is 745.16 volt. Then VC is 599.20, so that you have to different. VA is equal to 745.16 minus 599.29, you got a 145.86. So this is vertical 149.87. Then this voltage will be the voltage target. So this target will say the resultant voltage. V equal to square root of 177.9 square plus 145.87 whole square, you got the 230 volt. This is the way we got. So this angle you can measure by the protractor. You can see the theta is 39.36 degrees. And this circuit, you can see this, the current iron flow, the 0.2 Henry's inductor, 63 microfarad capacitors, and resistor 15 ohm. So you have to find out the frequency F0. So the frequency is 1 by resonant frequency 1 by 2 by square root of LC. Then you can calculate 1 by 2 by into square root of 0.2 multiplied by 63 microfarad. You got a 44 by 8 volts hertz. Impedance need to calculate. Impedance is 15 ohm. Angle theta is 0 degree and power factor is 1. So this is the end of lesson. You have to do this practical exercise for a series RLC circuit. Now this is the RLC circuit. Then also you can know about the parallel RLC circuit. So that we solve the problem in the low voltage AC circuit, parallel RC circuit, AC circuit. At the end of this lesson, students should be able to determine the circuit quantities and the characteristics of the AC parallel circuits, drawing label the impedance and power tracker for the AC parallel circuit, drawing label the phasor diagram for the AC parallel circuit, list a number of practical applications for a AC parallel circuit. So this is a parallel circuit is a common. It is a sublime voltage VD equal to VI equal to VC equal to VR. This is a common. And so in this case, you can see that the current through the inductor led the applied voltage by some angle less than the 90 degrees. So the inductor current is IL. So the led the applied voltage by 90 degrees. And also the current through the capacitor lead the applied voltage by 90 degrees. So IC is a lead the applied voltage by 90 degrees. The current IR, the current through the resistor is in phase with the applied voltage. So this is for this inductor, capacitor, and the resistor are connected in parallel. In this case, the inductor current is less the voltage by 90 degree, let the angle less than the 90 degree. Capacitor current is lead the voltage above the 90 degree, and resistor current in phase with the voltage. So ID is a total current. The total current is a algebraic sum of the branch current. I total is I1 plus IC plus IR. And then this is that you can see on the motor. Sublime voltage 240 volt 50 hertz. I total the motor current is a 4 ampere angle minus 30. II 3 ampere angle 0. So in this case, our VD as we calculated. So that will be the II is a 3 ampere angle 0. And on the protector we draw it. So that angle with the IM is 4 ampere angle minus 30. So this angle you have to make the parallelogram. So this was the parallelogram. So then you can see there's our total currents. So this will be the total current here. The total current is ID equal to 6.75 angle minus 70 degree. And also another this program. This is the capacitor reactance 23 ohm and the resistance values are 18 ohms are connected in parallel. And there's a current flow into the resistor IR, current flow to the capacitor IC, and total current is ID. Supply voltage 230 volt and 50 hertz. So in this case, we can draw the horizontal VT is a vector. So the IR need to be calculated 230 by 18, you got a 12.78 ampere. So this is the II 12.78 ampere angle 0 degree. I see the 230 by 23 is a 10 ampere. I see so 10 angle 90 degree. So the II is a 12 by 7 angle 0. I see the 10 angle 90. So 10 angle 90, you can draw it like this. So then you have to make the combination. And then you can have this one, the total current. And this angle had to 5. This total current ID is at 67.23 and get 38 degree. And this is what we calculated. Now there is this problem. In this case, resistor and the inductor, resistor inductor connected in series. The current flowed into the resistor inductor is 20 ampere power for 5.7. The current flow to the capacitor is IC. Capacitor value 100 microfarad. They are connected to the 240 volt and 50 hertz supply to the current is IT. You have to find the total current IT to the impedance ZT, power factor, and the real power P. So in this case, we calculate the ID equal to I1 IL plus IC. So in this case, the VT is a horizontal. Then current flow to the inductor, so 20 ampere, power factor 0.7. So in this case, angle theta can be calculated. Cos in 0.7 is 45.57 degree. Therefore, the current is 20 ampere, angle minus 45.6 degree. And also that you guys are VDR and then IL, you have to draw the protector. And then IC need to be also be calculated V by AC. V by AC is 1 by 2 by FC, AC is 1 by 2 by SC. So by this way, you can see there's 31 by 83 ohm and 242 and 31 by 83, you got a 7 by 54 ampere. Then the IC is a 7 by 54 and get 90 degree. So that angle IC you put here, and then you have to draw the vector diagram. Then you got the total current ID. The total current ID value magnitude is you find one this way, 3.5 ampere and gets minus 25.7 degree. This is the way you solve this problem. And in the middle, in this case, you already know that total current ID 3.5 ampere and get minus 25.7 degree. IC is 7.5 ampere and get 90 degree. I is 20 ampere and gets minus 45.6 degree. So this one you also do the calculation. So we calculate the Z equal to the V by ID. So 240 by 15 by 54, you got the impedance is 15 by 440. And angle theta Z is 25 by 7 degree. So Z equal to 15 by 50, 15 by 40, angle 25 by 7 degree. And lambda equal to cos theta. Then you also calculate cos minus 25 by 7, you got a 0.9. And the P equal to power equal to the power equal to VI cos theta, the VI into the 240 minus 3.5 and then 0.9, you got a 3 by 348 watt and 3 by 35 kilowatt, you can calculate that. And then resonant organ in the parallel circuit. In this case, this happens when H and equal to AC equivalent. So in this case, IT is equal to the H and AC are cancel each other, appear to be the open circuit to the source. This means that when the resonance happens, impedance Z is equal to the RT. So the circuit impedance is the maximum at the resonance F0. F0 is 1 by square root or 2 by square root of LC. So therefore, this circuit you see there's a supplying current voltage is a VT, supplying current is a IT. The current flow into this inductor is a IL. So N and R is connected in series. So this IA is this is a 5 ohm, and IC capacitor current is a IC. The capacitive reactance value 10 ohm, resistance value 4 ohm. So there is a no I in series with L. So this is the in this ID component. So that when this is as a resistor, inductor, and the resistor, inductor, capacitor connected in parallel to the current ID supply with 20 volt. So that you have to draw the VD. So in this case, we draw the VD. The II is the 20 divided by 5 ohm. So this is the 4 ohm. So you got this 5 ampere. IA is the 20 divided by 4 ampere. So the IR current is 5 ampere. IL current is 20 divided by 5, 4 ampere. Then IR and IL will you draw here. So IC current is 20 by 10, 2 ampere. So you allocate an IR, IC, IL. This value you connect IL minus IC. The combination you got the ID. You got the ID's value is you can see the 5 by 39 and get minus 21 by 8. So this is the way we finish and then we have to do the practical exercise.